All right, hello. Let's look at let's solve some exercises. Let's solve some questions on different types of simple machines. Let's look at this question. We have a question that says the velocity ratio of an inclined plane at 60 degrees to the horizontal is what? The velocity ratio of an inclined plane at 60 degrees to the horizontal is what? So the sketch of that is something like that, an inclined plane. Okay, so the load, this is the load. So it's like a slopey so it's a slope that helps us to move a load. So you can usually roll a drum, like rolling a drum to the back of a truck. So it's easier to roll over this inclined plane. So this is what it looks like. This is the vertical height through which the load is carried, and then this is the actual distance the effort moves through, your effort. All right. So like I said, this is the vertical height. This is the vertical distance that the load covers. While this is the distance that the effort of the person moves through. So velocity ratio, remember, is distance moved by effort over distance moved by load. Okay, so it's basically the hypotenuse of this right angled shape, hypotenuse over the opposite, given this angle 60 as a reference. So hypotenuse over opposite is basically the inverse of sine theta. So we're given the angle at 60 degrees from the question. So just apply 1 over sine theta, that's 1 over sine 60, punch that into your calculator, and you get that the velocity ratio is 1.155. Velocity ratio is either 1 over sine theta or distance moved by effort over distance moved by load. All right, let's look at this another question. An effort of 40 Newton is applied on a machine to lift a mass of 60 kilograms. Determine the mechanical advantage of the machine. Acceleration due to gravity is given as 10 meters per second squared. An effort of 40 Newton is applied on a machine to lift a mass of 60 kilograms. Determine the mechanical advantage of the machine. So, what are we given? We are given the effort, that's E, as 40. We are given the mass, the load. Now, remember, load is a force, so the mass has to be converted to force. To the mass is converted to weight force by multiplying by its relation to gravity. So 60 times 10 is 600. And very important, mechanical advantage is always load over effort. So it's also known as force ratio. So put that in, get 15. This is another one. A machine of velocity ratio 6 requires an effort of 400 newtons to raise a load of 800 newtons through 1 meters. A machine of velocity ratio 6 requires an effort of 400 newtons to raise a load of 800 newtons through 1 meters. Find the efficiency of the machine. So let's state what we're given. We're given the velocity ratio as 6. We're given the efforts as 400 newton. We're given the load overcome as 800 newtons. All right. Now, what's the efficiency of the machine? So we need to obtain efficiency of the machine. What's the formula for efficiency given that we are dealing with, given what we have, because we have different formulae for efficiency, but use the one that is relevant to the quantities you are given or the terms you are given. Like we have velocity ratio, so use the one of mechanical advantage of velocity ratio. The relevant formula for the formula we're going to use for efficiency is mechanical advantage over velocity ratio. Okay, as a percentage times 100 over 1. Okay, so mechanical advantage we can easily find using load over effort. Okay, so just like I said, there are different formulae for efficiency, so choose the one that is relevant to the particular question. Like this one, mechanical advantage over velocity ratio. So we're giving velocity ratio straight up as 6. We don't need to calculate for it. It's already given. So mechanical advantage is load over effort, all over that, so times 100 over 1. So slot in the values, velocity ratio 6. Mechanical load as given as 800. That's the load that is overcome over 4 over effort. Effort is 400. So 800 over 400 is 2. So put that in, and the efficiency is calculated to be 33.3%. All right.